down again.
Oh no.
Well, hey there, everybody. Hey. It is 2 hours UTC, and it's time again for Astronomy Daily Live. So this is just a casual, fun. It is 2 hours UTC. Got to kill my. It's time again for. Got to kill this dumb thing. Okay, there we go. Sometimes I remember to do that, and sometimes I don't. But yes, I think for the fifth, I'm going to look here at my video manager page. This is the 1, 2, 3, 4. So yesterday was the 5th day in a row that I got a thumbs down, at least one. So,
hey, my name is Bobby, everyone, and sorry to jump in and stuff, but I think whoever's been disliking should change it to a like.
Yeah, well, like I say, at least, and I'm getting a lot of echo, Bobby.
Oh yeah,
ton of echo, tons of echo. Can still hear echo. Echo. There it goes. Oh, no, it's back. It was gone there for a second. No, it's still there. Technical difficulties right out of the gate. Bam! Yeah, I can still hear it.
Yeah,
I mean, it is my incredible voice, but yeah, I don't want to hear that. All right, so cheers. Nope, I can still hear it.
Okay, I'm going to be right back.
All right. Bobby's great. He's absolutely great. He keeps everybody on their toes. For sure. So yeah, and I don't know what his setup is like, and I've reminded him a couple of times. If he put some headphones on, that would do it. But I don't think he has any, or yeah, I don't know. Anyway, so this is just a fun, casual get together of friends, practically every single day, to get together in sort of this virtual way, and just forget about everything else and concentrate on the universe. Think about why things are the way they are. Look at various observations. Look at instrumentation. Look at the various kinds of objects and materials that we find in this universe, and try to maybe understand a little bit about why it is the way it is, why it looks that way, why all those whys. So and that's why at a very, very young age. Hey, are you back? I don't hear any echo, but I don't think Bobby's hearing me.
Okay, I'm hearing you.
Oh, you are. Good. And I don't hear any echo whatsoever.
Yeah, I got a USB microphone and a Bluetooth speaker.
Okay. All right. Well, cool. So yeah, from a very, very young age, I realized that really I'm interested in a lot of stuff, right? Lots and lots of stuff. So it's like, okay, well, what are there people who are interested in lots and lots of stuff? you know, everything out in space. You know, I mean, what makes everything go, right? What kind of people are those? Well, those are the astronomers. You know, the physicists and the chemists, you know, the scientists in general, um, trying to get a handle on, you know, what's going on. And I've got a lot of background.
Okay, yeah, sorry about that. I just turned on the fan because what is my Wacky, my dog, for some reason has been messing with other dogs, so he's like punished and stuff. So I'm trying to like dull the outside noise and see if that's gonna work.
Okay, yeah, we'll give that a try. That's not too bad at all. There was an initial loudness, but now there's barely anything at all. So cool, cool. So yeah, I realized, you
Yeah,
know,
once the band gets started and really gets kinky, it's quite all right.
excellent, excellent. So yeah, um, always liked astronomy, you know, because it is you know, the study of everything. The astronomer has to be aware of subatomic processes and practically simultaneously has to think about, you know, large scale structure, you know, clusters of galaxies, superclusters. Um, and we think about everything in between too, right? So you know, there really isn't anything that astronomy um, doesn't touch in some way. Um, so yeah, it's a big science. Like I say, it's both very broad and very deep, broad and deep, and um, so that covers a lot of area, right? Um, and so there's a lot that can actually be done in the science of astronomy, and a lot of things are being done, um, despite the fact that there are actually very few um, professional astronomers. What did we say? There was 10, 10,000, 20,000? Don't remember, in the entire world. Um, and I think I would probably broaden that to um, also include, you know, people who sort of considered themselves professional astronomers, because, you know, I mean, how do you define a professional astronomer? Do they have to have paperwork, you know, confirming that, you know, they jumped through various hoops, um, or is it, you know, that they are doing astronomy and getting paid for it, right? Is that a profession? I think that's the definition of profession. Um, is that you're, you know, doing something and getting paid for it, and I guess you have a certain level of expertise in that. Um, so yeah, I would think that there, and maybe somebody in the chat can remember what that number was, because we talked about it, oh, I don't know, a month or so ago, a couple months ago, about the number of astronomers. But yeah, I think probably what I said last time and what I'll say now is that it's probably less than 50,000. Probably a lot less than that. So, hey there, Tim Robinson. Nice to see you in the chat. Now, yeah, Atta, I don't know if I acknowledged you in the chat or not. So, hey there. And Tom is in the chat as well. And as everybody already saw, but I will do the formal introduction here. Bobby is on the panel. Hey, Bobby.
Hey, what's up?
Everything going well?
Oh yeah, all is fine. Yeah.
Cool. Cool. Yep, all things are pretty good on this side of the rock, Tim. Yeah, don't I don't have very many complaints. Not too many. I can't really think of any. So that's how it goes. That's how it goes. But cheers. I've got the hydrogen hydroxide here, but wow, I'm already running a little bit low. So wow, I'll have to keep an eye on this. Okay, so 100,000. I think that's probably quite a few more than what it actually is. But 100,000 max, yeah, I would say so. All right, well, cool. Let's yeah, I was commenting before the live stream started, Atta, that yeah,
Sam, by the way.
What's that?
I was telling Sam, what's up?
Oh yeah. So I was just commenting on your thumbs up thing. You know, actually thumbs up before the live stream starts. So yeah, I think that's pretty interesting.
There is a way to find out who's been dumbing down those videos. I think I cannot believe they don't want to make that type of technology, because I think YouTube is more of a closed based system. So,
yeah. Who knows? I'm not at this
least
point.
with Facebook, you know who's who.
True. Yeah. Well, you know, you can't see who is viewing your videos at all, right? So, I mean, I don't know who watches these later. I don't really know who is watching them now. I can look in the chat and see who's in the chat, but that doesn't necessarily mean that, you know, they're also watching. So yeah, but I don't mind. I don't mind one bit. That thumbs down is an indication that this is getting out a little bit, and that's okay. That's all right.
I remember we were like having fun against the thumbs downers and stuff. I also did that one time to one of the songs, like from George Michael's "Wake Me Up Before They Go." I think like so many of those that dumb down the video don't wanna go.
Well, exactly. But yeah, you know, like I've said, you know, before, I'm, you know, any reaction is a good reaction as far as I'm concerned. So you know, if they want a thumbs down, you can thumbs down. That's okay, because that's a reaction, and that is what I'm interested in. So you know,
okay, I gotta argue.
The worst thing that can happen, right, is that everybody goes away, right, or stops watching, right? That's the worst thing. So as long as somebody is getting on here and thumbing down, that's all right with me. That's okay. Plus, you know, it's
now just wait till you get more of them and stuff, and you talk about, man, you really want to find out who they really are, so that you can feel the wrath. So when we see them, we'll make them fear the wrath of God and stuff.
Well, yeah, well, maybe I'm just being, ignorant or something, but I'm just at this point I'm not really worried about that. I'm I'm more into, sharing this passion that I have for astronomy, um, and thinking and talking astronomy, and you know, letting anybody in who wants to come in, and if they can
And I
behave
think
themselves.
Tim is actually telling the truth. He always thumbs up videos, or not all. If I don't like the video, he still does it anyway for great effort, or none at all, never a down. And also, I ran into a lot of people on the web. You just gotta like ignore them and don't let it hunt you down and stuff.
Look, I've been on the internet since 1987. Um, so I mean, I've seen it all. I've seen it all from the beginning, right? Um, so yeah, back when there was just dial-up bulletin board services and Gopher. Does anybody remember Gopher? Gopher was awesome. Gopher was the first. I don't know if it was the first, but it was at least one of the first browsers, in that it was a text browser. Because when you're running at 300 baud or 1200 baud or something, it's you're you're happy with text, right?
You to be honest with you, whenever I first started going online and stuff, we had the way we are, way it's at right now, with HTTP and email and stuff like that. But you should remember the good old dreaded dial-up sound.
The good old and dreaded what?
Dial-up.
Oh, dial-up. Yeah, no, but I mean, at the time that was like very cool, right? I mean, just the other day, um, uh, I sat down and watched one of my favorite movies of all time, and that is War Games. You remember War Games?
Oh, I've
Uh,
seen that so many times, man.
I'm not surprised. So I mean, uh, when I first saw that and saw his computer setup, I was like, oh my God, that's incredible, right? Because that was like state of the art, really really cool stuff, and so yeah, and that what I think that movie came out, 1980, 82, 83, 84, something like that. Um, uh, but yeah, Tim in 1980 was also 19. Um, uh, but no, I guess I wasn't doing those two things. When I was 19, most of 19, I was just starting at the university. So I was on a I was on a rocket, and that rocket was named Astronomy, and I was riding that rocket, and it's a rocket that I'm still riding to this day. And sometimes it throttles back a little bit, and sometimes it throttles up a little bit. But yeah, to this day, I continue to ride that rocket. So, all right. Well, very, very cool. Let's get back into. Before I get into Barnard Star, um, uh, yeah, Tim, the only thing that I can say about that is that being on a rocket does mean that you miss a lot of of sort of normal things. So everything else, is just sort of whizzing by, and it's like, whoop, there it goes. Whoop, there it goes. So yeah, no regrets, but definitely missed out on sort of normal life things. So yeah, I was a focused laser beam riding a rocket, and it's like that was it. So that's broadened a little bit over the years, but still relatively focused. Yeah, to this day. So all right, well, before we get into getting back into Barnard Star, I just wanted to alert everyone that the Leonid meteor shower is occurring pretty much as we speak. I don't know, and we can actually go and look when the predicted date and time for the Leonids is. Let's do that first. I'm going to get myself set up here, and then I'll share my screen. Meteor shower 2018. We're going to see it, time and date. Okay, here, I'll start sharing my screen now. The Leonids are kind of a interesting meteor shower, and I think I've mentioned this before. But every 33 years, Earth goes through sort of a thicker chunk of this stream of debris, and we get an actual meteor shower, right? And the last one, they had been occurring every 33 years. It was 1933, 1966, and then for some reason it sort of jumped a year. 1999 wasn't really a great year. 2000 was the big year. There was something.
Just out of curiosity, are there any live feeds now? I might be able to try to catch one right now, if so.
Oh, that's a good question. There are a number of all sky cameras that you can watch. There's one up at Kitt Peak. Pretty close to me here. I think there's one up at the MMT as well, which is also close to me here. Another thing.
Doing a live feed as of now, or what?
Yeah, another thing that you can do is you can go over to slooh.com, SLOOH.com, and if you register as a user, you can go over to their telescopes over at the Canary Islands, and they have an all-sky camera there.
Now, what about YouTube feeds? Any YouTube feeds?
Oh, I don't know. Yeah, you have to just do a search and find out. So yeah. Okay, so it peaks overnight on November 17th, 18th. So yeah, this is it. Tonight is the night. And of course, the Leonids are named that because they appear to be coming from the direction of Leo, which is going to be rising local time at midnight. So pretty much anywhere where you are on Earth, if it's midnight, then Leo is probably just beginning to rise in your east. If it isn't midnight where you are, then Leo is either up or it hasn't risen yet. So, but yeah, I I definitely recommend taking a look. It's best to observe these things after midnight, right after Leo has risen. So get up 2 or 3 in the morning, whatever you want, 1 o'clock, 3, 4, maybe, um, and go out and the best way is well, I guess it depends on circumstances, but if you can get like one of those lounge chairs that leans all the way back, then you can just sort of lay flat on that, or just um, put a sleeping bag or a blanket or something on the ground, and just lay flat on the ground, and that's your best view. Is right at the zenith. So, because you can cover pretty much the entire sky. We can see almost the entire sky with our eyes. So that's pretty good.
Okay, the third, and are the linears are the ones that has the slower velocities?
Uncle Bill, I believe so. These guys are well, yeah, I don't know. Let's try to find out.
Yeah, I got clouds as well. Also, I'm seeing on my weather panel.
Clouds? Well, yeah, that's no fun.
That's why I'm asking if there's any live feeds, either on Facebook, Twitch, or YouTube.
Yeah. Well, as I said, there probably is. So yeah, you'll just have to take a look, see what you can find. Let's see. Okay, so it says here, at least according to Wikipedia, that the Leonids are a fast-moving stream, which encounter the path of Earth and impact at 72 kilometers per second. So I think that's pretty fast. Let's compare that to the Perseids. Let's see, Perseids. Let's see, do they give a velocity? 58 kilometers per second. So the Perseids are slower than the Leonids, and the Perseids are pretty fast. So yeah, to answer your question, Uncle Bill, I think the answer is no. I think they're faster. Too many clouds. Tim, it's both, and it's actually faster, right? It's a little bit faster. All right, well, cool. So, and I think I posted this site before. Let's go all the way back to the beginning. So this is the International Meteor Organization, right? And I'll post this in the chat here so you can properly see that. Boink. So from here, you can go to, I think it's visual observations. I think. Yeah, here we go. So live zenithal hourly rate graphs. So you click on that, and then you can choose your shower. All right, so we're going to choose the Leonids for 2018. Hit OK. and we get a plot. And as you can see, the number of meteors is on the rise. They're already up to 15 per hour. So that's pretty good. Not a lot of data, right? Let's see. Based on 79 observed Leonids, grouped into 7 intervals. So not a lot of data there yet. 8 observers. But it looks like they're on the rise. So we'll see how and when these actually peak. So, you know, I guess I'm expecting this to go up even more. But yeah, you know, they have an error bars here, you know, an error range as they call it. So that's pretty cool. So yeah, this is kind of a neat way to keep track of various meteor showers. And you know, I think this is a pretty comprehensive list, right? I mean, this is showing. I mean, I don't know most of the meteor showers. You know, I guess I know the popular ones, but I don't know all of them. And so, yeah, it's like, you know, the Lyrids for 2018. Let's see. I assume that has happened already.
And I want to confirm or check something, but I'm not sure yet. But I think there's a way that you can track meteor showers on a radio and stuff, like an SCR or communication receiver. I want to try to confirm that with geos as well.
Yeah, you can actually hear them. I don't know what the frequency is, but I think it's either UHF or VHF. Pretty sure, because
I'm just responding right now. He's typing a message.
Cool. They're yeah. Back when I first heard about being able to listen to meteor showers, there was some kind of trick that you could do with your TV, the receiver on your TV, and that could pick them up. So that's why I say, you know, I think it's probably VHF or UHF or something. But anyway, here are the Lyrids from last April, and as you can see, you know, it sort of went to a peak, and then it, you know, fell back off. And this kind of data, you know, gives us a lot of information about the structure of the cloud that we're moving through, and you know, because it isn't a nice smooth increase here, right? It's going up and up and up, and then it drops, and then, you know, suddenly doubles, and then drops again. You know, so, you know, it's as with everything else, right? It's a complex structure, and we're basically, you know, drawing a line through it, and taking a very, very, very small sample. So, but yeah, this actually peaked at 17, so that's pretty good, I think.
Okay, Jill's is saying that if you tune to some frequency of a known powerful station in VHF that you won't be able to hear, you might be able to see it for a second or two when a meteor enters the atmosphere.
Okay, cool.
So,
ooh, here are the Perseids. 4,041 observation periods. There we go. So you can see here that again, it's not necessarily smooth, right? There's some activity way out here, right? A few weeks before the actual shower, and then there's nothing, but there's a big peak here. Then it starts to rise, and it goes up and down, up and down, up and down. Then the big peak. So, yeah, it's kind of interesting to look at the structure there. Just the structure itself. What's that, Bobby?
Hang on.
Yeah, I'm starting to hear that. I'm starting to hear that echo again. Any way to fix that?
Is it all good, or you can still hear it?
Let me see. Nope. I guess. Yeah. No, I can still hear it.
Okay, because I don't see any uppings on the on my end and stuff. So.
All right. Well, I can still hear it. It's kind of faint, I guess. So, yeah, whatever.
Okay.
Anyway,
I think as long as it's faint, it should be all right, huh?
I guess so. Yeah. Yeah, that's cool. Anyway, so this is a really, really cool site, just to sort of see, what was going on, right, with various meteor showers. Here's a Epsilon Geminid shower, which never heard of it. Very, very, very low counts, right? 3 per hour. So there's some pretty dedicated individuals, right, who are doing this. 13 observers. So, 13 people were out there, either, maybe not, actually out, laying out in the cold and all that, but, maybe using an all-sky camera, some kind of live feed, like, what Bobby's talking about. And you can sit in the comfort of your own home where it's nice and warm and out of the wind and all that, and, count meteors, or, write some software to do the same. So that's possibly how this data is being produced. Because you can, once you know the radiant, the point from which all these objects appear, then it's really, really easy to confirm whether, a certain meteor you saw is part of this shower or not. If it's part of the shower, it is going to be pointing right to that radiant point. Exactly. So if you observe a meteor and it isn't, then it isn't part of the shower. It's part of another shower, or it's just a random thing. Both of those things, well, all those things are happening at the same time. So, you have multiple showers happening at the same time. And you have, these random pieces of dust that are just floating around, not necessarily associated with anything. See, what makes these meteor showers do what they do. I'm going to stop sharing here. Is that the Earth is actually passing through a debris path, and that debris path is left by a comet. So I think in the case of the Leonids, we can confirm this. In fact, we saw it here. Leonid meteor. Leonids. So this shower is associated with Comet Tempel-Tuttle. So, at least the idea goes is that, as these comets move through the solar system on their way in and around the sun, and then on their way out. And they may have an orbit, they may not. This one does, right? So it has an elliptical orbit that just so happens to cross the path
Tim,
of Earth.
if you want, go ahead and post it about that headset.
What's that? Headset with a really good mic.
Because right now I got like the LT stuff. I got like a $6 Bluetooth speaker and a $20 USB microphone.
We are just top of the tech pyramid here. Cheers. All right, well, anyway, if it's clear, go out tonight, and like I said, if it's after midnight where you are, then now is the time to go out and look, as long as it's clear, right? But anyway, so yeah, the 2000 Leonid shower was a true meteor shower, right? I mean, for a very brief time, very brief time, maybe about 30 minutes, maybe a little bit less, 20 to 30 minutes.
Thanks, Tim, by the way.
Yeah, cool. All right, well, cool. Let's move on. Let's get back to Barnard star here. So, cheers. And I'm going to go back to my Burnham's Celestial Handbook first. That's sort of my first grab. When I want to find out something, I'll usually go to Burnham's first, before I even go online. But Barnard star is in the constellation of Ophiuchus, which is over around Orion, if I remember correctly. And so I'm going to be going to Ophiuchus here. Here's Ophiuchus. Ophiuchus is a big constellation. But Burnham's Celestial Handbook has a section on Barnard star. And we were looking at a few of these things already. Really the only exceptional thing about Barnard star is that its proper motion is very, very high. In fact, it's the highest of any other star in the sky, which just means that, at least according to us, relative to us, it's moving the fastest in the sky. And it's moving really fast, seriously fast. I mean, over the course of a few years, you can see that it's moved relative to the background stars. It's absolutely amazing. But Barnard star is also the fourth closest star to us, after the triplet Alpha, Beta, and Proxima Centauri. Barnard star, I believe, is next in line. It's about, well, at least according to Burnham's, I think they said it was something about like six light years away. Is that right? Let me go back here and look. Yeah, 6 light years. 6 light years. So when we look at a little bit more modern info here, Maybe that'll change a little bit. So we looked at this a little bit yesterday. And let's see if there's anything. This I thought was kind of neat. They're kind enough to show this table in here, and it's an entire page. And it says list of stars of large proper motion. So this is a list of the stars that have, at least at this time, right, were the highest proper motion in the sky. And so here it is. So, and you can see that Barnard star is right at the top. Kind of hard to see, sorry. That terrible focus. So let's see. There's Barnard star that, at least according to this, now this is a little confusing because this is saying a magnitude of 11.3. Now, I thought that it was magnitude 9.5. I'm a little confused about that. That's okay. I'm not going to sweat it too much. They are identifying it as an M5 star, so that's a red dwarf. Not quite sure what LFT. Not quite sure what LFT stands for. Notes in the last column. 1 is invisible companion. 2 is white dwarf star. 3 is flare star. 4 is close visual companion.
And these are like a list of stars that's around the Barnard star, right?
Well, yeah, this is a list of stars that have the largest proper motion. So they seem to be moving fastest in the sky. And so there's Barnard star. There's Captain's star, which is in the constellation of Pictoris. There's a star called Groombridge 1830. That's a bright star. It's like 7th magnitude. And not moving quite as fast as Barnard star, but it's up in the constellation of Ursa Major. There's and yeah, so this is a big long list. Now Alpha Centauri is in here, but it's moving about 1/3 as fast as Barnard star, and there's a few others, right? So cool, very cool. So Barnard star is definitely the fastest moving observed star, for sure. So let's go and take a look. I'm going to cheers one more time. Oh yeah, and Tim, that list has changed. We can probably look and see if we can find the current list, because with missions like Gaia that are providing measurements of proper motions, very, very, very accurate and very, very precise measurements. We can not only know the proper motions of more stars, but we can actually discover more that way too. So it's very cool. Let's take a look and see if we can find the current list of like the top few proper motion stars. So let's go back over here and let's see, hide that. Let's go.
LFT catalog 110 by 10. So catalog of stars for proper motion is seen at half a feet or half an inch.
.5 tenths of catalogs of stars with proper motions exceeding 5 arc seconds. 5 arc seconds per year, or not quite sure what the 0.5 arc seconds is there. Nothing moves that fast. I think Barnard star moves about 10 arc seconds a year. So okay. So anything more than that. Oh, okay, I got you. So yeah, if that's like per year, that's a pretty good list. Oh, here we go. Oh, so that's kind of interesting. They're showing the actual motion of Barnard star here. Oh, where'd it go? What is this? Okay. Huh, so they're actually seeing it wobble. Huh, that's kind of neat. Okay, well, we weren't looking there. Let's okay, we're not going to find anything there, I don't think. 20, the top 20, here we go. Okay, so this is kind of small, sorry, but let's compare it, right? Let's compare it. So let's see. First on Burnham's list is Barnard star. Yep. Next is Captain star. Yep. Then is Groombridge 1830. And then LaSalle 9352. Here we go. Huh, okay. Well, in Burnham's, the next one after this is what they're calling Cordoba 32416. And in this catalog, which is from Hipparchus, so that's a little old, they're calling it whatever that is. And then there's this unnamed one. And see, 1331, 540. I wonder if that's that one. So there's an unnamed one, which at least in Burnham's says it's Ross 619. The proper motion amount is about the same. Oh, but the position angle's wrong. Magnitude's right. Anyway, so yeah, so 61 Cygni A and B are next. Lalande 21185. And then this says Wolf 359. This says Epsilon Indy? I'm not quite sure. Okay, well, there's Epsilon Indy. So for some reason, Wolf 359 isn't in there. That's kind of interesting. Yeah, so there's a little bit of a difference. Omicron 2 Eridani, that's in here. And then there's a Wolf 489 that's on my list that isn't here. And then there's Alpha Centauri C, which is Proxima Centauri. And then Burnham's lists a star called BD plus 5 degrees 1668. I don't see that one here, but they've got Mu Cassiopeae. So, yeah, it's kind of interesting. There are discrepancies. There are differences between these two lists. So, I don't know. Maybe worth investigation by somebody. All right. Well, cool. Let's see. I think that's pretty much all there was in Burnham's about that. So I'm sort of thinking, I don't know, should we could go over to Gaia and actually grab that data and look at it. We could do that. I don't necessarily think that would be incredibly interesting, but well, let's do it anyway. So let's get the coordinates here in the sky of Barnard star. We'll plot this out and see if we can find him. The Barnard star. There's right ascension and declination right there. So let's do it. Let's go back. So this is Gaia. This is the Gaia database interface. And I'm going to, I don't know if I can just copy and paste this or not. Let's find out. It'll give me a green if it is acceptable. Oh, it is. Okay. Groovy. Let's see if I can do it with degrees and minutes and seconds too. That would be astonishing. Whoop, I think I've got the, there we go. Okay, so that goes over there. Let's see if this goes green. It's not. Okay. So I'm going to just get rid of these things. And I'm actually going to get rid of these also. Just, it's showing a green, which means it's okay, but I'm going to just be consistent. Radius, let's take it out a little bit. Arc minutes, 10 arc minutes. And, well, 19th is more than enough. And let's just make sure that we're looking at the proper motion in RA and the proper motion in DEX. So we are. Okay. So at that point, we can show our query. So this is just an SQL database query. If you've never seen one, that's exactly what it looks like. Pretty simple as long as you know the language. Okay, so let's submit this query. And we got a lot of stars, 2,376 stars in that 10 arc minute radius field. It is down to 19th. So, you know, we don't really need to go all the way down to 19th. Let's go to 16th. There'll be a few less stars to deal with. Yeah, 295. That's a nice number. So this is already going to be in a comma separated list. So let's just download it. And I know where I save it, so I can, I'm just going to go over here and do it right here. So let's move this thing. Downloads. Whoop. Whoop. Oh, there we go. Downloads. Or we'll call this Barnard star. So somewhere in this list, is Barnard star. So I'm going to get rid of the first line because it isn't a number, but here's all of our other stuff. So we can actually look and see what these are. But what I'm going to plot is I'm going to plot proper motion in right ascension versus proper motion in declination. So let's go to GNU plot. And we have to tell it that the columns are separated by commas. So set data file separator, comma. And then let's plot, oh, let's take a look here. So 1, 2, 3, 4, 5, 6, 7, 8, and 9 are the proper motions. So columns 8 and 9. So plot Barnard star using 8 and 9 points. Point type is around, and point size is 1. And we'll make them black. The 1 should be way out there. Aha! There it is. So there is guaranteed. There is Barnard star. That dude right there. So let's see. So how can we do this? Let's probably the easy. Well, what we can do, in fact, we can cheat a little bit. We can go back over to our database and we can order this, order the output list by any of the column values. So let's order this by right ascension, proper motion, PMRA. Okay, so we'll get the same list, but now the first row should actually be the object with the highest proper motion, which is going to be Barnard star, right? So then we don't have to think about it. All right, yeah, see, so it's the same number, of course. So let's do that again. And we'll come over here and we'll just right over this one. So the first one there should be it. And I think this is showing, let's see, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I think column 10 is the magnitude. So yeah, this is 8.2. It's saying it's 8.2. So okay, I think what I'm going to do is I'm going to grab just this one. So then I can do this. So now let's plot it as if it is in the sky. Okay, so let's do that. And we're going to do Barnard star using 2, 4, and what is this, 16? Yeah. So 16 minus the 10th column times 0.3, say. That's our variable. 2, 4, points, point type 7. Color 8, point size variable. Bam. Whoop. Set data file separator. Okay, so that's, let's see, that's not quite what it looks like in the sky. We've got to flip this around. So 269.65 to 269.25. 269. Okay, so that's what it looks like in the sky. So now let's just identify Mr. Barnard star. I'm going to have to zoom out a little bit to get this all on one screen. Barnard star 1, right? Isn't that what I called it? We're going to be doing the same thing, except line code is going to be red. So whichever red one is here is Barnard star. So there's Barnard star right there. And then all the other background stars. So that's pretty cool. That's an easy way to identify it, at least. And at least in this field of view, it's the brightest star there is. So that's pretty cool. There's this. You notice this this line of stars here? I seem to recognize that from Burnham's. Is that true? Yeah. Look at that. I'm going to so okay, cool. This is almost okay. I'm looking at it a little. I'm looking at the book and I'm looking at the chart at the same time because I want to be able to help you see what I'm seeing, but most of what I'm seeing is actually out of the field of view. But here, I'll show you. So you can see this group of stars, right? It sort of makes a sort of a greater than sign, right? Or I'm sorry, a less than sign, right? Or a V. That makes sense, right here. So if you look at this chart, and I will stop sharing my screen here. You can see that that same less than sign is in both of these photographs. So
it's like the book is a little bit outdated, or what?
well, no. It's just this thing has moved a significant amount since 1960, right? If you look and see where Barnard star is, right? It's in 1960. He's right there, right? So this thing is actually pointing right to him in 1960, right? Well, look where it is at the time of the Gaia data release. Share my screen again.
Yeah, so it kind of like moved quite a bit, huh?
So, see, it was way over here, and now it's way up here. Look at that. So it's moved that much in.
I'd like to say good night, Anna.
Good night, Anna. So yeah, it's moved that much in 50 years or so. So pretty cool. Pretty cool. All right. Well, neat. Well, we didn't get incredibly far into Barnard star, but yeah, I think we're probably done with looking at it through Burnham's Celestial Handbook. I think over the next couple of days or so, we will turn to the internet. And ooh, look at that! What I can do! Wow. Yeah, we'll turn to the internet and see what see what sort of our more modern observations and data is on that, including any kind of new information on this potential planet. Looks like it's very, very likely that there's one there. They need to look a little bit more, but yeah, so cool. And Barnard Star itself, as I said, I've seen a couple of things about some flares that were observed. So this might be a pretty interesting object, and I know that it's well studied. So yeah, I think we will continue the Barnard Star saga tomorrow. So until then, I think I'm going to get out of here for now. So have a great evening, a great day. Make sure to subscribe, hit the thumbs up, hit the thumbs down, whichever you prefer. It's sort of your thing, right? I mean, if you like this.
We got a lot of litigators coming in as well.
What's that?
Check the chat.
Check the chat. Check the chat. All right, Patrick. Very cool. Yeah, all right, so I'm going to get out of here.
And I just want to let you know that tomorrow I probably will not be here on the panel.
Okay. Well, sounds good. It sounds like you're going to have some fun elsewhere. So that's all that matters, right? It's all that matters. So, yep. Have a great time. And yeah, I think that's it. I'm going to get out of here for now. So peace, cheers, and all that. And I will see you on the spin. One more spin around. It's getting dizzy. It's, it's like, whoa, we're always spinning. I don't know. So take care, everybody. Hang on. We're all right. Bye.